go to page 98 in your journal and look at this core concept here. We're talking about the rational root theorem. So it says when we have a polynomial, we take p factors of the constant term a0 and factors of the constant term an. So these numbers here, we take those factors and put p over q. So what this is saying is this will be my q and this will be my p. So factors of 7, which is my p, are just 1 and 7, and factors of my q are 1 and 2. And the theorem is saying that for f of x equal to 0, so anytime that the function equals 0, the answers are in the form p over q. So my options would be plus or minus 1 over 1, because that's p over q, plus or minus 7 over 1, plus or minus 1 over 2, and plus or minus 7 over 2. And all I'm doing here is taking my p values and dividing them by my q values. To make this look a little bit nicer, we could say my factors could be plus or minus 1, plus or minus 7, plus or minus a half, and plus or minus 7 halves. So these numbers represent all the possible solutions to f of x equals 0. So let's take a look at the example in your notes. So example 3 is going to use the rational root theorem, and we want to find all the real solutions of this polynomial. So to do that, my q is 1 and my p is 20. So my x value can be plus or minus all of the factors of 20, because we're just dividing by q, which is 1. So q is 1, p is 20. So my factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, 5, 10, and 20. So if I picked one of these numbers, it might be a factor of this polynomial. So what I'm going to do is test a few points. I always like to start with 1 and negative 1, and I'm going to use synthetic division so that I can try to factor the polynomial to find all the real solutions. So I'm going to set up 1, negative 8, 11, and 20. When I do this, I get 24 as my remainder, so this is not a factor. So I'm going to try negative 1. So now I set up synthetic division for negative 1. Bring down the 1 and go ahead and start that. And you should get 0 as your remainder, so that means that negative 1 is a factor, which means x plus 1 is a factor of this polynomial here. And then what's left over? X squared minus 9x plus 20. Can we factor that? So yeah, what two numbers multiply to 20 and add to negative 9? It's x minus 4 and x minus 5. So now we put all the factors that we have together and we can get our final answer. Remember, we are solving. We're not just factoring. So look at the example here. Find all real solutions when it equals 0. So now we set each factor equal to 0. So from this, I get x plus 1 equals 0, x minus 4 equals 0, and x minus 5 equals 0. So what are my three answers? And those should be my real solutions to this polynomial equation, negative 1, 4, and 5. Now, looking at an example where the leading coefficient is not 1, this makes it a little more tricky, and we actually don't really like this problem, so we're going to cross it out and make up our own problem. So I listed my factors of p and my factors of q, and now I'm going to divide all the numbers by this. So my options for my possible zeros are plus or minus 1, 2, 3, 4, and I'm just taking all the factors and dividing them by 1. And then when I divide all the factors by 2, I only get plus or minus 1/2, 3/2, and 9/2, because think about when I divide 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. All of those are repeating, so we don't have to write them. Now, I'm going to pick a test point that works, so I'm going to pick 3. And it might take you a few tries to pick one here, but we're going to help you to pick those points. So then I write my coefficients, and I bring my number down and use synthetic division to see if 3 is a factor. And we can see that 3 is a factor, which means x minus 3 is a factor here, and 3 is going to be one of the zeros. And then I want to try to factor what's left, so 2x squared plus 5x minus 12. This is a hard trinomial, so I want to try to factor that. So you can see I factored 2x squared minus 5x plus 5x minus 12, and then I brought down the x minus 3 factor, and now I can set them each equal to 0 to get all of my zeros. So when I solve for my 3 zeros, I should get 3/2, -4, and 3. And these are going to be the zeros of my function. If I was asking you to factor, you would just want to give me this answer here. Now looking at the monitoring progress, just cross out number 6. We'll do number 5 together tomorrow, but we're going to skip number 6.